So welcome to Anatomy of the X-ray machine and how X-rays are produced. Now it's going to be a little bit confusing and you're not going to understand everything completely, because when I was in tech school I didn't understand what in the world Dr. Thomas was talking about. I had no idea. It took me going to automotive school and taking 3 hardcore electrical theory classes for me to actually understand this stuff. So there's certain things, don't beat yourself up if you don't understand it. It's okay, it's not that big a deal. Let's talk about the basics and some of the questions that they ask, because there is a lot of little pieces and parts in here that they do ask you about. So when it comes to X-ray production, what ends up happening? Here we have the cathode and we have the anode. And what this is representing, you love my picture, I know. What this is representing is the glass envelope, and that is kept in a vacuum. You'll understand that in a minute. So what ends up happening is, first, when you start depressing the pedal, you're going to go into standby mode. That is when you hear the anode starting to do the noise. All that is the anode spinning if you have a rotating unit. So the X-rays or the electrons are going to come in through a wire. So this is a magical wire. And then they're going to do this fun little spinny thing. And then the wire is going to exit out of the glass envelope. One of the parts that we just made here is called the tungsten filament. And this is the most important part of X-ray production, is this tungsten filament. Because what ends up happening is you have a whole bunch of electrons coming down this wire. And the fun thing about electrons, when we just simply have a wire, they don't stay in the wire themselves. They actually float around the wire. And then once you start doing this spinny thing on the wire, they end up making what's called an electron cloud. And they end up spinning around the wire itself. And then some of the electrons will go ahead and escape out. However, I can prove this to you that electrons do come outside of the wire. If you put your hand on an unshielded wire, you're going to feel like an electrocution sort of situation. That's the electrons going through your hand. They don't stay necessarily in the wire. That's why you always have shielded wires. So, but in here we don't have a shielded wire. We want them to make this electron cloud. Now, you're in standby mode. As you're in standby mode, you've got these electrons starting to fly around your wire and your tungsten filament, making this beautiful cloud. As soon as you actually depress the pedal all the way, you cut connection. So the electrons want to escape, but they can't. They don't know where to go. They don't know what's happening. So they come shooting across, electrons, 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 and they hit the anode target. And I always remember this as an anode because I can visualize, since I'm a visual learner, I can visualize what it looks like, and the anode's kind of shaped like an A. I know it's stupid, but if it helps you. So, back. The electrons are going to come shooting over and hit the anode target. And then right here is where the X-rays are actually produced. This whole situation is just electrons. This coming into contact with the anode target is where X-rays are produced. And then depending on the angle of the anode is going to shoot down. Now, making these electrons is a pretty heated situation. The anode target can reach over 1000 degrees Celsius. It can get so hot. So we do have cooling units, and the cooling unit can be water or oil, just like in your car, to help cool down this target. That is the whole purpose of the cooling system. So some of the other parts that we didn't talk about, we talked about the tungsten filament, which is what's going to heat up when you go into standby mode. We also talked about the tungsten target on the anode. That's where X-rays are actually produced. And 99% of the energy produced is going to be heat. Only 1% is going to be X-rays. The other things we didn't talk about is the focusing cup. The purpose of the focusing cup, it is going to be around the filament itself, because if this is the filament, this is the focusing cup, just like in the name, it's to focus the electrons, making them go one place. Instead of shooting everywhere, they need to go right to the anode target. So focusing cup is focused, that's where they're going to shoot. And that's nothing that you can control, it's just what's in the machine itself. So they're going to come across, have the focusing cup, the tungsten filaments, and the tungsten target, and the electron is going to come across, shoot down, and then we make X-rays. For more information about ShakyPaws VTNE review, check out the links below.